I'm very happy to be here. Thank you for your invitation. I always wanted to visit ZKM. It was my bucket list, so I can tick that off. So thank you for your invitation, also for the very smooth organization. So my talk today is entitled Machine Learning and the Image of Algorithmic Thought. Of course, machine learning has come up over and over this morning, so I'm sure that I don't need to explain too much today what we mean by this expression. I believe also in the afternoon, leading scientists in the field will offer their insights into current research. So for the sake of clarity, I will just very briefly mention again that when we speak of machine learning, we are denoting a set of artificial intelligence techniques that provide computer programs with the ability to modify themselves when exposed to large amounts of data. This learning is in turn applied by the same programs to make informed decisions. Deep learning, which is more specifically the topic of my presentation today, is a type of machine learning that relies on layers of artificial neurons to process information. These artificial neurons are connected and they influence each other in a complex web of interactive units, somewhat like a biological brain is understood to do. A lower layer of neurons performs a computation or a calculation and transmits the result to the layer above, enriching the final outcome that is to be outputted by the layer at the top. Deep neural nets, then, are said to learn because they can tweak their calculations and modify their interactions by tuning parameters or weights via processes of activation and backpropagation amongst layers, until the desired output is finally produced. We know that currently deep learning are much talked about as they promise to accelerate the computational automation of today and to fuel the digital transformations of tomorrow. Although artificial neural nets have been around for decades, they are a core technology of connectionism, a biologically inspired approach to AI that emerged in the 1980s. It's only now, thanks to big data and increase of computing power, that we have begun to capitalize upon artificial nets' potential. And computational problems that we thought we could not tackle for many years, such as recognizing objects or understanding speech, are being significantly improved. This condition has been described as a quiet revolution or as a new season after a long winter in AI research. A computational renaissance, so to speak, brought about by a novel way of doing AI, which is in fact drawing from very old cybernetic ideas. Along with the excitement, however, it also comes with a caveat. Machine learning in general and deep learning in the specific is often portrayed as a black box technology. It's possible to say, in fact, it has been said, the machine learning programs are black boxes because their algorithms are proprietary and close to expection. In this respect, it's often stressed that although these algorithms have a great impact upon society, they cannot be held accountable for the consequences of this impact because they're close to public scrutiny. This situation poses great societal challenges. When legal, political, and economic expertise and authority are increasingly expressed in algorithmic terms, invisible powers emerge and consolidate. Of course, I agree that deciphering the black boxes of deep learning is becoming more and more urgent because their influence upon our world is becoming greater and greater every day. The issue that I would like to focus on with you today is, however, that machine learning in general and deep learning in the specific is a black box, also in a much more technical sense. In computing and in engineering, the expression black box indicates an object or a system that is viewed uniquely in terms of its inputs and outputs, and whose internal workings, therefore, remain concealed. In other words, when we approach a black box, we are interested only in stimuli and responses. We take into account what goes in and what comes out of the black box, but not its inner components and behaviors. Because of the way in which deep neural nets operate, relying on hidden neural layers sandwiched between the first layer of neurons, the input layer, and the last layer of neurons, the output layer, deep learning techniques are often very opaque, indeed illegible also to the programmers that originally set them up. So deep learning as a subset of machine learning works, but in more than one sense, we don't fully understand how. The claim that we don't know how it works is deeply interesting to me. While I acknowledge that some computer and data scientists might take issue with this claim, there remains the fact that once a deep neural net is trained, it can be difficult to fully understand, and by understand here I mean also to fully represent why it makes a determinate decision or gives a particular response to a certain input. Explainability is a real issue in deep learning. So what I want to do in this talk is to speculate whether the popular statement, we don't know fully understand how deep learning works, may allow us to say that machine learning is challenging the simulative paradigm in computing, a paradigm that's been looming over AI research since Turing's 1950 proposition of an imitation game as the standard for machine intelligence. So in the very short time at my disposal, I can only sketch these arguments, which I should say is part of a research which is still in progress. What I would like to do today, however, is to discuss the opacity of deep learning vis-à-vis questions about the image of thought, as these have been introduced and developed in philosophical critiques of representational thinking. So let me start then precisely by clarifying what I mean by image of thought. To put this as simply as possible, the image of thought is a set of presuppositions regarding what thought is, what is possible or legitimate to think about, and in what ways one might do so. In this respect, we could say that to have an image of thought means to make thinking dependent or subordinate to features and factors that predetermine and restrict what thinking should be. So I borrowed the expression images of thought from the work of the French philosopher Gilles Deleuze. However, the phrase denotes a long-standing and yet to be resolved issue in philosophy, that of presuppositions, an issue that two German thinkers also confronted full-on. Hegel, when he argued that the presentation of knowledge cannot be separated from knowledge itself, and Heidegger, with his quest for an original and authentic account of what is called thinking. For Gilles Deleuze, the image of thought is a problem that is the most necessary and the most concrete, quote. A problem that is articulated in Deleuze's philosophy in terms of a critique of recognition and representation as the basis of thinking. So Deleuze argued, we live with a particular image of thought, that is to say, before we begin to think, we have a vague idea of what it means to think, its means and its ends. Now, in order to exemplify this point, it's useful to consider the well-known opening passage of The Discourse on Method by René Descartes. I'm not going to read the whole quote. I'm just going to say that here Descartes is arguing, good sense is the best distributed thing in the world. The power of judging well and of distinguishing the true from the false, which is what we properly call good sense or reason, is naturally equal in all men. Here Descartes is telling us that to think is to seek truth. He's telling us that thinking is naturally and rightfully oriented towards validity and veracity. This is something that, for Descartes, everybody knows. This relying on an everybody knows is for Deleuze a clear example of what dogmatic image of thought is and what a dogmatic image of thought does. This image is a representation that subordinates thought to externally imposed directives by assigning an a priori nature to the act of thinking. Deleuze's response to this everybody knows, no one can deny, was to revive the Nietzschean war cry. Quote, to think is to create. There is no other creation, but to create is, first of all, to engender thinking in thought. End quote. For Deleuze, this means that a new radical idea of philosophy is necessary against any attempt to reduce thought to a preformed and predetermined identity. Going back to AI now. In more than one sense, reducing thought to a presupposed or restrictive identity is what AI does and has been doing all along. Representation is a fundamental idea in AI research. While the history of AI is very complex and there is no single point of inception for this interdisciplinary field of inquiry, few will object that the dominant strand in artificial intelligence research from the post-war era to the late 1980s was what is known as symbolic AI, often also dubbed good old-fashioned AI or GoFi. Symbolic AI is a collection of methods that attempt to develop intelligent systems based on rules and ascribed knowledge. As the name implies, this method exploits the representative power of symbols, which are put together in a specific way to aggregate and process information. A contemporary glittering success in Symbolic Ai would be Google's knowledge graph, which is composed of piles and piles of nested if-then statements that draw conclusions about concepts and their relations, and which at present can answer more than 1/3 of the 100 billion and counting monthly searches that Google processes. Despite the undeniable achievement of Symbolic Ai, a crucial disadvantage of the symbolic approach is the fact that for a learning process to occur, both the rules and the knowledge of the system must be hand-coded. Knowledge elicitation and feature extraction are indeed in the hands of the programmers, which have to tell to the machine what kind of things the machine should be looking for in order to make an informed decision. Of course, this is not only very costly, it's also quite time-consuming. Connectionism is an alternative approach in AI research that attempts to make up for the awkward learning procedures of Symbolic AI. As I mentioned earlier, connectionism arose in the 1980s as a non-symbolic approach to machine intelligence. Its aim is to build computational systems that are inspired by what we know about the brains of humans and other animals. There are many types of connectionist models, but the most common one is that one that employing the parallel distributed processing of artificial neural networks, which have today found renewed fame thanks to the success of contemporary deep learning techniques. So if Google's knowledge graph is a contemporary example of successful Symbolic AI, much of the rest of what Google does at present can be considered as an effective instantiation of connectionist principles. For instance, the revamped version of Google Translate, introduced to the public in November 2016, runs on artificial neurons powered by Google Neural Machine Translation System, and it's often cited as one of the most accomplished examples of neural net research. Well, having said so, in relation to both Symbolic AI and connectionism, the claim that I would like to advance now is as follows. Although it's certainly true, the connectionist approach tried to do things differently, so to speak, favoring low-level modeling in order to allow for the emergence of neural nets' autonomous classification criteria, connectionism is still a representational enterprise. On a quite fundamental level, it can be observed that, of course, we don't actually build artificial neurons, but simulations of them to be run on a digital computer. Equally, from a technical perspective, it should be noted that neural nets process information via representations, with the difference now that these representations have become distributed through a large number of processing elements. In addition to this observation, however, I would like also to stress that just as Symbolic AI is representational not only because it employs symbols, but also, and most importantly in my view, because by doing so, it presupposes an understanding of what mental activity is, a computational theory of mind, as often been said. So equally, connectionism is still trying to assign a shape to valid cognitive activity. This might be now a physicalist shape, based on ideas of the brain rather than of the mind, but nonetheless is still an image of thought. So the dream that we might at some point be able to replicate intelligence in an artificial system, or in other words, the dream that an artifact might exhibit a thinking capacity comparable to that of living beings, involves having an idea or an image of what the thinking capacity may be or might do. In the case of deep learning, based on the principle of connectionism, it is the neural network that becomes the central metaphor for thought. So we must therefore be careful when considering philosophically the statement, deep learning works, but we don't know how. And also when addressing related issues of AI explainability. Technically speaking, the crux of the problem of explainability in deep learning lies in the fact that the hundreds of hidden layers of artificial neurons nets, that is to say, what gives to the net its depth, does not return to the programmer a comprehensible representation of their doing. Deep, which means very large, neural nets lack model interpretability. And it's for the reason that, when considering why a machine took that decision or made that prediction instead of another, we remain ignorant at worst and agnostic at best. Again, whilst the representation of symbolic AI are relatively easy to interpret, connectionist models can be described only in very general terms. We can describe the learning algorithm or count how many units the system is composed of. Yet, the magic that happens inside the black box, well, remains magical. Returning now to the philosophical problem of the image of thought, I will suggest the presupposition of what thought may be and do ground popular analogies between artificial neural networks and the biological brain. Of course, nobody has ever claimed or will claim that an artificial neural net is a complete representation of an actual human brain. The complexity of the human brain is still beyond computational reach. In fact, it currently also defeats any attempt to provide a fully scientific account of it. My point here, however, is that whilst the human brain is considered to be the black box par excellence, similarly, we say the artificial neural net's opacity is due to their black box complexity. The implied presupposition will be then the following. Since everybody knows that a brain is what performs cognition, anything that's meant to simulate its working must be generative of cognitive capabilities too. In other words, the assumption is that if the deep net resembles, however roughly, a brain, it must to a certain degree be doing what the brain does, that is, thinking. With this consideration in mind, I want to argue, therefore, that addressing the long-standing philosophical problem of the image of thought vis-à-vis contemporary AI research shows us how deep learning from a scientific but also a technocultural perspective is still predicated on what, elsewhere, in previous work, I call the simulative paradigm in AI. So in some of my previous work on the topic of the computational automation of thought, I argued the simulation constitutes an established, although not unifying, not normalizing, framework or reference for the multifaceted field of AI. Famously, the imitation of intelligent behavior was the Sussex threshold that Alan Turing, already in 1950, set when considering the cognitive capabilities of computing machinery. His well-known imitation game allows machines to be credited as intelligent on the condition that a human is not able to distinguish the machine from another human on the basis of the answers given to questions put both to the machine and the human. So while it's true that Turing never explicitly claimed that all human thinking is computation, it's nonetheless the case that his imitation game opened up a comparative link between human cognition and mechanical calculation. The first symbolic AI initiatives that came after Turing's inquiry took on this implicit link and made it explicit. Vis-à-vis the development of computationalist theories of the mind in what was then the newly emerging discipline of cognitive science. So in developing this consideration, a central speculative hypothesis that has guided my research lately is that pertaining to the possibility of challenging this simulative paradigm to open, in other words, an autonomous epistemological prospect for automated machine thought by freeing the latter from the expectation that computational thought, or AI itself, is an attempt at simulation. In this respect, the question of explainability can be mobilized, I hope, to consider what I have often defended as the profound alterity of computational thought. So the question for me then becomes, and I'm glad to see that it resonates with many of the talks and the scope also this day together, can computing machines be generative of thoughts in ways that are profoundly alien to humans because they are so inherently computational? So from this speculative perspective that we are here testing, and that I am advocating, the 2015 victory of the Chinese game of Go, achieved by Google's deep learning system AlphaGo, reveals what we should perhaps have known already, and we should have been made aware by the chess victory of IBM's older and much more traditional machine Deep Blue, which was scored over its human opponent in 1997. But computational successes show that these agents won not because they think or behave like us, or they can approximate how we think or we behave. Rather, they won because they think or behave in a manner that is completely different to the way in which we think or behave. So to go now towards a conclusion, I want to say the decision-making, of course, we know the decision-making of autonomous artificial agents guided by deep learning affect millions and millions of people every day, and also influences the decisions that these people in turn make for themselves. Recognizing this, the European Union has declared the EU citizens can challenge legal or equally significant decisions made by algorithms, and thus appeal for human intervention and for human interpretation. This piece of legislation is part of the new General Data Protection Regulation, or GDPR, that will come in effect on the 25th of May 2018, so in less than a month. Although the specific article, Article 22, concerning explainability has been criticized as vague, and what exactly is granted by is still debatable, this piece of legislation is important culturally and socially as it sketches the contours of what we could call a right to explanation. Moreover, it's important also because it illegally acknowledges what philosophy and critical theory have been arguing all along, that automation and autonomy are conceptually mutually implicated, and that any decision-making calls for responsibility. The challenge for philosophy and critical theory in this respect is to problematize not only algorithmic images of thought, something this philosophy and critical theory have been doing all along with their critiques of computationalism, instrumental reason, and the computational theory of mind. What philosophy and critical theory also need to problematize, in my view, are the images of both algorithmic and human thought get to inform AI technologies. While explainability is often stressed as a key issue at the core of the evolving relationship between humans and machine, for me explainability is particularly interesting because it's opened up a line of investigation into modes of cognitions and forms of reasoning that are emerging within calculation, and thus they are still within the space of abstraction, but which also surpass the boundaries of identity, recognition, and resemblance. I'll stop it here. Yeah, I saw your sign. Thank you.
Thank you very much. Unfortunately, we have just time for one more question, but I saw a sign, so.
Yeah, thanks for the interesting talk. Could you give us an idea of what a good explanation could be from a deep AI model or any machine learning algorithm?
Well, I guess it depends. A good explanation for whom? For us? For humans. A good explanation for humans would be I guess it would be a critical explanation, like something that could determine the limits and possibility of why a determinate choice has been taken or made instead of another. So it would imply a form of criticality rather than awareness of consciousness. If we want to remain in the domain of the pure formalism, it will be like a form of self-criticality that, for me, would account for something that we perhaps can trust. Thank you.
Thank you very much.